Hi everyone, welcome to section 3.7. This is other ways to solve quadratics. In the last section, we looked at really general ways to solve quadratics, like with a graph, and we just looked at some of the properties of quadratics and their graphs. So now we're going to talk about more concrete ways to actually solve them. So the first way we're going to talk about that is factoring. And so what does it mean to factor something? So to factor means you are determining what to multiply to get a certain expression. So we're going to talk about several different ways that you can factor to start. And the first one is called the greatest common factor. And the greatest common factor is the biggest common factor between a set of terms. So the greatest common factor, in some cases, it can be kind of really easy to see. So for instance, in this first polynomial, 3x plus 3y, just looking at this, what do they have in common? They both have a 3, right? So that 3 is the GCF. So what we want to do is we want to factor out this GCF, i.e. greatest common factor. So to do that, you write the 3 in front. And it's kind of like you're dividing the 3 out of these two terms. That's the way that you can think about it. So if I divide 3 out of the 3x, that'll leave me with x. And if I divide 3 out of the 3y, that'll leave me with y. So look what happens if I actually try to multiply this back out. So this is what it means to factor, right? If I distribute this, I get 3x plus 3y. So this can be a really nice quick way to check whether or not you found the right solution. Okay, so looking at the next one, so the GCF here, be a little careful with this. Now I've got 3xy plus 6xz. Now, it's not just the number that they have in common, so both of these are divisible by 3, but also they share the letter x. So in this case, my GCF will be 3x. So that's what I want to factor out. So I'll write the 3x here. Now, in dividing that out, so when I divide 3x out of here, I'm just left with y. And then when I divide the 3x out of here, I'm left with 2z. And again, you can multiply that back in if you want to get 3xy plus 6xz. So if you're ever unsure, you can just check that way. So C is left up to you. Why don't you pause the video, figure out the GCF, hit play when you're ready. Okay, so here everything is divisible by 5, so it's definitely part of the GCF. And then looking across this whole thing, so there's actually an x in each one of these, right? So my GCF here is 5x. So when I take 5x out of this first term, I'm left with 2x, right? So think about how exponents multiply. X times x will give you x squared. So if I divide 5x out of this, this will just leave me with 2x. Then this will be minus 5y plus 3z. Oops, and I accidentally wrote both the GCF and the factorization up here, but that's okay. Please forgive me. Okay, so why don't you go ahead and just try these 3? Pause, hit play when you're ready to see the solution. Just factor the whole thing. Okay, so with this first one, so let's see. It looks like this will be 2x y squared. That's my GCF. Now, if you're not totally sure how you would figure that out, hold that thought. I'll talk about that in a second. So first I want to just factor this out. So this will leave me with 6 plus 5x y squared minus 7 y to the third. Okay, so notice that all 3 terms have an x and a y in them. And so now you want to find what is the lowest amount of that particular variable that it has. So in this case, I've got x, x squared, and x. So x is the smallest amount, just one singular x. And then for the y's, I've got y squared, y to the fourth, and y to the fifth. So you always want to select the smallest quantity of that variable. So in this case, I usually look for like the smallest exponent. So xy squared, those are the 2 smallest exponents since all 3 terms share those letters or variables. Okay. So with that in mind, let's move on to B here. So it looks like, let's see, I don't have a number that divides into everything, right? And then I've got x, y, y, z, and xz. So actually there's nothing that will actually divide into this. So trick question. This is already simplified. The other word for that is prime. And so we can just write that it's already simplified. Okay, so what about this last one? So now notice I've got x in everything, so I just want to choose the smallest x. So this will be 3x, and then to factor that out, this becomes 1 plus 2 minus, minus 2x, sorry, my bad, minus 2x minus 4x squared. Okay, so just a pro tip here. If you did not write the 1, so this is a really common mistake, sometimes people will divide out the 3x and they want to write a 0 here. You want to make sure that however many terms you start with, that's how many you still have in the parentheses. So I have 1, 2, 3 terms, so I still need 3 here. So if you are prone to the error of I just drop this out and say this is a 0, remembering that you're still supposed to have 3 terms here might help you remember that. Okay, so there's the GCF. So now let's talk about grouping next. So I think grouping is best understood with this example. So I'll show you. It's going to be AX plus AY plus BX plus BY. Now, write that down, and I want you just to take a second to look at it and just confirm to yourself that there is no singular GCF here. So once you've convinced yourself of this, there's no, I can't divide everything by A, I can't divide everything by X, like there's no one thing I can divide out. The next thing that you want to notice here, so there's 4 terms, so a lot of times grouping has 4 terms. That's not a hard and fast rule, but that can be a good hint that you might have to use grouping. And then the other thing is that when you look at these groups of terms, so look at these two. What do they have in common? These both have an A in common. And then what do the second 2 terms have in common? BX and BY. These both have a B in common, right? So that's the other thing that's going to tell you that you want to use grouping. So what you're going to do then is you're almost going to treat this like 2 GCF problems in some ways. So in these first 2 terms, I want to factor out the A, so I'll just write the A right here. And then this is going to be X plus Y. And then out of the second 2 terms, so now I'm going to factor the B out, so this is going to be times B. And then here's the X plus Y. And now, to keep going with this, so I want you just to pause for a second, and sometimes we almost don't recognize what we're looking at. Stare at this line, take a deep breath, and then just notice, so I have really now this term, and I have this term. That is what I've reduced this to. What is actually the GCF then between these 2 clusters? It's actually the X plus the Y, right? That's actually technically now your GCF. So that's effectively what we're doing now to finish this. So I'm going to write that down, that thing that they have in common, the X plus Y. And then the other pieces, so then you're just going to write exactly what's in front of the parentheses. So this A plus this B. So one way you can kind of think about this is if you can check that these have the same thing in both sets of parentheses, you write that down. They have to be the same thing in both sets of parentheses. And then to finish it, you just take what's in front of the parentheses verbatim. Now, you can write it like this, or you can write it like this, tomato, tomato, doesn't matter. I personally prefer writing it in this way, so I will write it like this, but if you write it that way, that's fine. You do you. Okay, so what I want to do first here is I just want to get you used to kind of that last step where you just kind of make sure that what you see in the parentheses matches, and then you kind of write out what's in front of the sets of parentheses. So in this case, so I've got X minus Y. So here's my X minus Y. And then what's in front of these parentheses? It's the 3 plus the 2Z. So that would be how this factors with grouping. So what I want you to do now is pause the video and do the next 3. Hit play when you're ready. Okay, so looking at this, I've got 3B plus 2C and 2C plus 3B. A little bit of a trick question here. These are actually the same thing, right? 3B and 2 plus 2C, you can totally mismatch the order of that and get the same thing. So it doesn't matter which way you want to write that. 3B, I'll just write 3B plus 2C. And then this is going to be 2A minus 5. Okay, so moving on to C here. So now I want you just to notice, this is Y minus Z and Z plus Y. These are not the same things, right? So you actually can't use grouping. So again, another trick question. So even though you were able to factor some things out, You don't want to go into that computer mode where you're just like, up and now I can just finish it because, you know, I feel like I should be able to. You have to actually confirm this, right? So just make sure you do a little sanity check before you finish it. Now, what about this last one? So now I've got the 4x minus 7, so I'm good to go there. Now, what do I write from the other two? 4x minus 7. So this is going to be 4z. And then what's this minus? This is minus, well, there's technically that invisible 1 here, so I'll just write that right there. So this will be 4z minus 1. So there's how you would finish the grouping for those. So now what I want to do is I want to do this last example, so I'll do the first one with you. And then you can do the other two. So looking at this, so what do the first two terms have in common for A? So they both have a 5 in common, right? So I can write that down. So this is 5 times x plus 2y. There's that. And then the second two terms, xz and 2yz, they both have a z in common. So I've got, if I take that out, this becomes x plus 2y. Now you pause, you take a look at your parentheses. I've got x plus 2y and x plus 2y, so I'm all good to go. So this will factor then as x plus 2y times 5 plus z. Okay, so like I said, why don't you pause the video here and hit play when you're ready to check the other two. Okay, so with these next two, so for this I've got, looks like 5x squared is going to be the common term, so then this will be 2 plus 3xy. Now be careful with these other two. So all I see here is a minus sign kind of in common. So what I'm going to do is I'm going to factor out a -1, and when I factor out a -1, that's going to flip the signs of both of these, right? So this will now become 2 plus 3xy. So it's very important that you have that matching, right? If this were 2 minus 3xy, we would have kind of like what was similar to that previous example, so they wouldn't match, so then we'd have a problem. But this will totally factor, so this will become, maybe I'll just flip the order, 5x squared minus 1 and 2 plus 3xy. Okay, and then for C here, so for C, so let's see, in the first two terms I'm going to factor out 3x, so this will leave me with x minus 2y. And then out of the second two terms, so just be careful when you do this. So it looks like these have in common, let's see, -10z, so minus 10z. So if I factor that out, this becomes x minus 2y. So again, if I'm factoring a negative out, so just think about what that does to the signs. This first term becomes positive, which we have, and then this second term, it was positive, but I factored out a negative, so now it becomes negative. So be really careful when you do that. So then your final answer here will be x minus 2y and 3x minus 10z. Okay, so I think that's good for this first section, so I'll see you guys in the next part. Thanks for watching.